It should be fixed. Yay. Okay. Hi everyone, and yeah, another launch today. Today we have the Metop-C satellite, which is the third in its constellation, and it will launch or it will be the third satellite that therefore it's the C. Its brothers A and B are already in orbit, and this will be added to the same orbit, so they can improve weather forecasts for. Actually, they improve. The other two satellites have improved weather forecasts. So the Soyuz ST-B will also have the Fregat upper stage, which was originally designed as a interplanetary probe, but they found out they could also use it for purposes that they used the probe as a tug to deliver everything in orbit, because the engine on the Fregat upper stage can light up to 20 times, so they can get you exactly where you want if you are delivering your satellites, or even multiple. There have been occasions where I believe 20 or even more microsatellites were launched with this launcher, and they did short burns between every deployment to get everything in its correct orbit. So it is called the ST-B, and there are two variants they launched from Kourou, which is it is a version of the Soyuz 2, and it is basically the Soyuz 2.1A and the Soyuz 2.1B, but it gets the name ST because of its fairing. It has a really wide fairing, and that's called the ST fairing, and then it gets the A and the B depending on its third stage engine. So you have the first stage, then you have the boosters, then you have the third stage, and you have the fourth stage, which is the Fregat upper stage. But the difference, the first stage is the same, and the second stage, so the first stage is called it's called the first stage when the 4 boosters and the core stage are lit. That's what they call the first stage. Then the boosters peel away, and they call that part the second stage, or actually the core stage, but they call it the second stage. And then the third stage is that's the stage that's on top of the core stage. But that one has the RD 110 engine, or the RD 124, and the 124 is more efficient than the 110. So that is what's the difference between the A and the B? And the A uses the 110, and the B uses the 124, and that's the difference between the A and the B variant. And the B variant has a little bit more lifting capabilities. So also with this launcher, I think that the launch pad itself is really special, because this is one of this is actually the only rocket I know that is suspended in the air. They ignite the engines and then they just let go of the rocket, so it is actually hanging there. And when we get views of the launch pad, you will see there are 4 arms that hold that are at the tip of the boosters that hold the launcher in. But when the engine starts firing, that is not actually the part that holds on to the rocket. There are 6 arms hidden within the concrete structure, within the 15-meter diameter pit. There are four black arms which hold on to the boosters, and then there are 2 which hold on to the second or the core stage. And then you have on top of the concrete plateau, you have the 4 boosters and the 2 arms. And the 2 arms provide electrical connections to the payload, and that's the upper arm, the first arm, and then you have the second arm, which is propellant to the core stage. And the first arm the top arm is providing propellant to the 3rd stage and airflow connection to the satellite. Tired Europeans, yes. But actually, when it launches, okay, I'm gonna cut over to a view of the launch pad. So here you see what I mean. You see a view of the upper arm, which is providing electrical connections to the payload and to, I need to get my check room back, hold on a second. And it provides fuel for the 3rd stage, so when they fuel it up, it comes through that arm. And that's the top arm is the first arm you see retract. About 20 seconds before launch, it retracts. No, even earlier, around a minute. And then this arm that's under it, it's the second arm that also retracts, but that's about 20 seconds before launch. Then you'll see the engines light up, and you will actually see that the rocket tries to push itself up, but it's held down by those 6 arms at the bottom. You can't see them, but they actually are what holds this rocket onto the pad. Because right now, all the loads are transferred into those 4 hold down arms that are sitting on the pad. It's actually sitting in those and keeping it closed. But when those 6 black arms fold away, that's the point of launch. They fold back, and then they, because of the thrust of the rocket, the rocket pushes up the 4 arms that are it was sitting on, but when it has enough thrust to push it away, it pushes itself away, and then it pushes them up slightly. And because of the way these arms work, there are tons of weights on the outside. Just moving it a little bit makes it so the whole stack moves. So that's how their arms fold out, and then the rocket goes up and flies away. So yeah, I'm going to try to turn on the sound now.
Example, the CEO of Arianespace. He's not in Kourou. He's here with us in Darmstadt. Stefan Israel, and of course our
Stefan is not in.
But Stefan Israel, tell us a little bit about today's mission.
Not in Kourou. That's special.
Today's mission is very important for us because it will be the 13th satellite we are going to orbit for EUMETSAT. The first one was in 1981 with Ariane 1, so it's a long history we have together. We have orbited
and the
Metop-A and Metop-B
satellite has now been switched to internal power.
And tonight is the night of Metop-C.
And the next few hours, not the whole night, what's going to happen?
So maybe what has happened in the last hours, we have 5 hours ago made the decision to fill the rocket. We have made this decision on the basis of the readiness of all systems, but also on weather forecasts, which are very positive for tonight. So the rocket has been filled, and now in a few minutes at 9:47 Kourou time, we are going to launch the rocket. The mission will last a few seconds more than 1 hour. We will lift off towards the north, which is not usual because usually when we go to GTO we lift off towards the east, but for polar orbit we lift off towards the north. We will have during 9 minutes.
Today this launch is going to a sun-synchronous orbit, which is
and then the Fregat is going to work for
orbit which every time when it comes over a place, it is the same time over there. So let's say it comes over you when it's 12 o'clock when it's noon, 12 o'clock. Every time when that same satellite comes over your head, it is 12 o'clock.
And this is always a very important satellite to prepare the transition with the next generation. And as you know, we are already developing this new generation with ESA. It's Metop second generation. But Metop second generation is a pair of satellites with different instruments on each one. And in fact, the full pair will be deployed and available and operational in orbits in 2024. So you understand how important it is for Metop-C to work until then and beyond. It's also very important for us because, as explained already, we will, for the first time, operate a constellation of 3 satellites. And
so the satellites are placed 120 degrees apart in the same orbit, so they cover the Earth.
We have developed a new ground segment, and one of the stakes
with
of this new
the
ground
3 of them,
segment
which
to operate at the same cost as
improves
if we had only one
the
satellite.
rate
So that's
of
also a technical challenge.
Sure. And we've
when
just heard
they've
some
mapped
user
the
experience.
whole
I
Earth.
mean, what does this launch tonight mean for the Met community?
I think you have heard so much that I would not repeat, but maybe I can translate the impact on weather forecast into socio-economic benefits, because we have done a number of studies on this. And today, the socio-economic value of forecast in the EU is more than 60 billion euro per year, out of which we can attribute 5 billion euro per year to these satellites. So you see what is at stake. It's not only to know whether it will be good to go to the beach in Kourou.
So also the rocket that is on the pad right now, after the launch failure of the Soyuz in Baikonur with the MS-10 Soyuz, they again took it apart, checked everything for the mistakes they've made with the MS-10. They took the boosters off, checked it, and then put the boosters back on.
And we have with us here in the Mission Control Center the senior consultant here at EUMETSAT, Mark Cohen. Mark, thanks very much indeed for coming to the floor. Mark, it's been quite a few years getting ready for today to launch Metop-C, but we are on the pad, so does that mean you're ready?
Oh, yes, we are completely ready. The launch campaign has been very long, has involved a lot of teams from industry and from agencies, also with the launcher team. But we are ready today. Today we have a green status.
Good, you're ready to fly.
Hello everyone, good to see you here. Yeah, good to see you too.
In Darmstadt at EUMETSAT. Any messages for them?
Oh, the message is that we are prepared the satellite here.
We'll go for lunch. It's exciting.
Tonight.
The views of this are always amazing.
The third one will come over and will bring its contribution, which is expected by the member states and by the users.
The views of this are always amazing.
Great, and of course we've been hearing how important Metop-C is as a part of the
They have
threesome.
tons of camera around
we
the
often
launch
talk
site,
about
which
satellite,
is really cool.
campaigns and projects as being teamwork, but this has really been a big collaboration effort, hasn't it?
This program was built around cooperation, so cooperation with the worldwide, with the United States, with the exchange of instruments, data, and services, but also in Europe with industry, but with ESA, with National Space Agency like NES for some instruments.
Thank you very much.
So the satellite is going through a so it's launched by Arianespace, then it is put into or in its correct orbit by ESA, and then it's operated by Metop.
And that was the range operations manager who just announced a key milestone.
I forget the name of the.
It's the last 10 minutes and 20 seconds before launch when the frigate upper stage, as you remember, I said the vehicle is divided into 4 stages. The upper stage is called frigate, and that's now entered the final phase of its launch sequence. And
so it will last over an hour, just over an hour. This mission. The ascent of the Soyuz plus the first burn of the frigate will take about 10 minutes, and then it will take about 55 minutes to get up to its highest point, do a really short burn of the frigate, and then deliver it into orbit.
We're going to take a look now at what's going to happen.
After
you see the booster separating.
Flight, the action of the 4 boosters, the second and third stage,
affirming the separation and then shutdown of the core stage separation and ignition of the third stage. Then the frigate will do a short burn and deliver it up to 800 kilometers.
Will occur at 52 minutes and 23 seconds, lasting 1 minute and 15 seconds.
If you wonder why I'm yawning, it is
6 minutes and 30 seconds.
it is 10 past half.
18 seconds after liftoff.
It is 22 2, so
arrived here at the
I did
Arianespace
sleep,
Center
but
on the 26th
still
of
it's
June. The teams have been preparing
tired.
ever since then for today, apart from a break over the summer holidays. So it's been quite a long launch campaign. The launch campaign is what we call the process of preparing the launcher and the satellites for today. And we're going to get an overview now of some of the activities that the teams
so
have been doing
on
during
the in Kourou they can have 3 parallel Soyuz launch campaigns, which is really special. They can have 3 Soyuzes being assembled at the same time. School tomorrow? Yeah, I have school tomorrow, but no tests, so I figured I could stream anyway. I'm gonna go to sleep after this launch is finished, so.
Metop-C has started propellant filling operation on the 8th of October.
So this satellite is quite a big one. It weighs 4 tons.
With launcher have started on the 19th of October with flight mating on payload adapter. Metop-C was transferred onto the Fregat stage on the 25th and encapsulated.
Should I turn up the sound of the stream a little bit?
Of the Fregat preparation, the 3-stage underwent the standard pneumatic and electrical tests in the MIG building.
And also the
integration and testing. Also, additional
you can see
were performed, which involved dismounting of the lateral boosters.
That's what he said. They dismounted the boosters to check again for the to check the pins on top of the ball joint. No, it's okay. And yeah, the rollout is quite a bit faster than at Baikonur. There you could shortly see the black armed was talking about earlier.
Once the ground installations and the
so this launch pad is different from the ones in Baikonur because they rolled there is actually a building, and they roll it through the building, then put it onto the launch pad, and then they roll the building onto the rocket and all the arms. Then they put the satellite on. And then just before launch, the building opens, its doors and rolls back, as you can see on the back of the satellite. And to be fair, I'm planning on building this launch pad.
For the Fregat upper stage has already started, and we're coming up now to the start of the final phase of the synchronized sequence for the main launch vehicle, so the first 3 stages.
I'll be getting up at 6:30. I'm getting up at 7.
And 9
but
seconds.
Yeah,
so
you have to have
what we're looking at here
something.
Is the outside of the Jupiter control center.
You want to do something for your launches, so
the nerve
that's
center,
what I'm
if you
doing
like,
today.
of the spaceport.
And the difference between the older versions of the Soyuz and the Soyuz 2 is basically that this Soyuz can roll around its axis and the older Soyuzes can't. So the Soyuz FG can't roll around its axis. And
in here.
I don't think there's an older
of course,
version
because Soyuz is a Russian
still
rocket,
launching,
we have joint
but it can't
Russian
roll around its
European
axis, and the Soyuz 2
side by
can.
side.
So it doesn't matter
the
how you
teams in
put
here
the
are
launch site,
responsible
but
for
in
everything to
Baikonur
do
they can
with the
actually
launcher, the
rotate
rocket,
the whole
and the
launch pad
base, so making sure that the launch site
around
operations
the
are
long
all,
axis
done correctly
and put
being
it on the right
responsible for the
launch
flight
azimuth.
readiness of the vehicle. In
But
Baikonur,
over here they don't
in
have to do it
Kazakhstan,
because the rocket rolls
cosmodrome
around
there,
its axis
the
and
launch
then
control
pitches down
center is actually in
range.
several bunkers underground. That's about 50 meters from the pad. Here, at the Guyana Space Center, it's in a protected building, 1 kilometer from the pad.
So
Passenger
3.5
Metop-C
minutes to launch.
is the
So
last
first
in
you
the
will
current
see the
series
top
of
arm
Metop
retracts
satellites,
at
as we
about
were hearing,
around 1 minute.
waiting up there inside
Then at 20
the vehicle
seconds
for
you will
liftoff.
see the first arm
the joint
retract,
program.
and at
EUMETSAT,
T
the
minus
European
16
Space
seconds you will
Agency,
see
along with their
the
partners, the
rocket
French
come to
Space
life. You will
Agency,
see the first
and
flames
US
start to
National Oceanic
or the
and
first flames are
Atmospheric
visible.
Administration. No.
Then it will run on 40% thrust for
When we
until
get to
a
look
few
at
seconds
the
before launch. Then
rockets,
it will
actually you can see it on the screens there, we have
go
it.
full
At the
power,
bottom you can
see if the
those
engines
4
are
swing
working, and
arms.
then
They
it
are
will
blue.
go up.
Now they are holding the launch
And then
suspended over
around
the
2
flame
minutes,
torch on
a
the
little
pad.
more than over
And they
2
stay
minutes
in
into
place
flight, the
because
boosters
the
will
weight of
have
the
run
launcher
out of
is on
fuel.
top of them.
They
But of
separate,
course, as it lifts away,
and then
they will swing away.
2
Thanks
minutes
to
after
counterweights.
that, the
On the
core
back
stage
then,
will
you
run
can
out
see
of
them there. At the
propellant.
bottom of
It
the
will
swing arms, you
separate.
can see the yellow
And
cylinders. Those are the
why there is
counterweights.
a letter structure between the core stage,
Right, he's just announced that
the lower stage and the
we
upper and the
have separated
third
the
stage.
umbilical lines, which are actually inside.
It is because
so you
they
can't
hot
see
stage,
them.
which
The
is
Grandmaster is called the
which
KZM,
means that
and it
they
houses
ignite
all
the
the
third stage
connections,
before the
electrical,
second
etc.,
stage has run out of fuel.
connecting the upper
So
parts of
that
the
means
launcher to
the there's
teams on the
no
ground.
need
And
for
underneath it is another
settling
mast called
the fuel.
VKM, and that's
So the rocket
hosting
will
a
go
whole
up,
set
the
of other
second stage will
connections.
still be
We'll see
firing,
both of
and
those
then
pull
the
away
third
just
stage will
before launch.
fire, and its gases will
What
go
about
out
the
of
ignition sequence? We switch on the engines
the ladder structure,
on
and then
Soyuz
the
16 minutes before
second
launch-
stage runs out of
seconds
fuel
rather,
and basically
before
drops
launch.
away.
And that's done on purpose so that we can throttle them up gradually and check that all the engines are working correctly. And then once they reach full thrust,
So in T minus 40 seconds, 14 seconds, the engines are running at 40% thrust, and then 1 second before
in the mission
launch,
control
they
center
ignite
coming
the
out
engines
have a
and
look at the launch with
to
their
full
own
power
eyes.
and launch the rocket. So we'll shut up now and turn up.
We are 1 minute to launch.
So watch for
live at the
these
Guyana
arms
Space Center.
retracting and seeing that everything
Metop-C
is
for
working.
EUMETSAT and its partners ESA, CNES, NOAA, built by Airbus Defence and Space and all the industrial teams involved in that. And we're travelling on board the 19th Soyuz to launch from the Amazonian jungle. The 8th launch this year from the CSG. There goes that mast.
Attention pour le début de la séquence d'allumage lanceur.
Our best wishes to the teams.
Top I0 moins 20 secondes. Largage du mât VKM. Allumage.
There you go, the two arms are retracted.
Attention au décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité.
Full thrust and launch. Yes, we have liftoff. We have liftoff of this Soyuz. Beautiful, beautiful images. I hope they can track it all the way to booster separation.
We are off. Metop-C has started its journey, flying through the very atmosphere that it's going to be sending us information about. We're heading out north over the Atlantic. And he's telling us that everything's going according to plan.
Korylov Cross will be
of course,
spectacular.
Metop is going
Yeah, it
to
is.
orbit
It
our
will
planet
be.
north to south, so we are going to deliver it
When
on
it
a polar
works,
orbit.
it is beautiful.
We're burning 20 engines at the moment. We've got 4 on the core stage and 4 on each one of those boosters.
That's where she's wrong.
Stabilization is
It's
correct.
one engine
And
with
the boosters
4
are doing all the work.
chambers.
They only burn for 2 minutes, but that's long enough for Soyuz to escape the pull of our planet.
It is
They are delivering 80% of our
one
thrust
engine.
right now.
It's not
Their
4.
job to get us away
The
from Earth's
the
gravity.
engine itself
Gravity, of course,
has
makes us
4
stick to our
combustion
planet,
chambers,
but
but
it
it's
stops
one
us
engine. They all
stops
these
us from
combustion
flying off into
chambers
space,
share
but it
the
also
same
makes it very
turbopumps
hard
and
for us to
and
leave,
the
so we need
same
an awful
fuel
lot of
line.
firepower to do that.
There they go. Boosters and separation.
And we can see
Beautiful
those
Kourou
4
cross.
boosters now being
These
jettisoned.
white plumes you could see were indeed the opening of the
And we have confirmation there from the range operations
liquid
manager.
oxygen tank, and it will
So we saw
release
those with
pressure
our own
and then
eyes, and we're now
a little bit
burning
of
the main
oxygen, and
core
then
stage, known as the
you can
block
see
A,
it then
and it's
tumbling
the engine
away.
that you can see there.
And this is the core stage continue burning,
Stabilisation correcte du lanceur.
And the stabilization is correct, all going according
and
to
they
plan.
have stabilized
From the range operations manager there.
Booster separation.
Altitude on the bottom left of the screen, 85 kilometers above our planet. The
So
distance, if
in
we were to
around
draw a
1
straight
minute
line
they
across
will
the
have
Earth,
passed
from the launch
the
pad to the
100
position
kilometer
of the
mark,
launcher,
and they separate
131
the fairing.
kilometers. And our speed on the bottom right, that's kilometers per second, of course, ladies and gentlemen, boys and girls, per second. So we are already traveling incredibly fast, and we'll be getting even faster.
And with the Soyuz 2, they
Amazing
updated
to see such beautiful pictures of the launcher. So those
the
clouds
guidance
actually managed to move
computer
away
and the
just
software.
at the right moment.
And do the vernier thrusters
Coming
operate
up
from the
to
same
the
engine?
scheduled
No, they
moment for
don't.
the
They're separate
fairing to be
systems.
jettisoned. The fairing being the front, the nose, the tip of the vehicle that we saw earlier,
well,
housing the
thinking
satellite
of it,
and protecting
they
it from the rigors
do
of the launch. Things
use
like
the same
acoustic vibrations at launch, which
they're
are very
attached.
loud, of course.
They are one system.
And we have separation
I think they use
of
the same
fairing,
turbo
which
pumps.
comes in two halves, which is why he said separation of the two halves of the fairing.
They might share the
our
same turbo
satellite
pump,
is
but
now exposed to space, and we are officially in
I should
space.
check that with
We are
images.
Coming
But
up to
we
150
have
kilometers
50
above
minutes
Earth.
of
We actually arrived in space
waiting
when we
time
reached 100
ballistic
kilometers, which
flight,
is the
so
official
we can check on
Kármán
Google.
line, the official boundary with space.
But from the top of my head,
Still
they
following
are
the launcher
part of
with our
the
cameras,
system.
which is quite remarkable to see it now. 4.5 minutes going deeper and deeper into space.
So hopefully you will be able to see the
Our trajectory on the
third
top
stage
right-hand
light
side of the
before
screen is the trajectory of the launch, our planned trajectory,
second stage
and the
burns
cross
out.
is the
but
actual position
I
of the
don't
launch
think
vehicle.
so. Was
We're
that the
starting to get further
separation there?
away. You can see there we're now 175 kilometers high, and we can
think it
still
was.
see the dot of
You
the
can see
engine.
just like two dots.
And we have
moving away.
separation there,
But
confirmation from the range operations manager.
right now
that we
they've
have now
lost the
separated
boosters and the
second stage
first
of
stage,
our rocket.
which means
Picking up
right now the
speed,
third stage is
close
taking
now to
over,
4 kilometers per second.
almost taking it up to orbital velocity.
All going well, all going according to plan. And here we have the flight directorate. As I mentioned earlier, we have a number of different desks in the mission control
So
center.
the
This is
satellite will be
the Arianespace
separated somewhere
top management team.
above Australia.
They take all the final decisions
because
in the event of any
over there they
unplanned
also
situations.
have a ground tracking station.
And here as well we have the joint Russian and European teams sitting shoulder to shoulder. So we can see our satellite for the first time. There it is, Metop-C at the front. So if you've never seen a launch before, to the left-hand side is what remains of the rocket. Then it's
so
sort of
the
in the
third
middle, just
stage,
after that
depending
white
on
fan
the
section,
A or B
is
variant,
the frigate upper stage, the gold round
has
circular structure,
a
and then right at the front
RD-124
is
or
the
the
satellite, and it's
RD-110.
all folded up, of course.
And
ready to
one of the
unfold
two
when
is more
it
efficient, and that's the B variant,
We've launched a
and
lot of
the less
satellites for
efficient
EUMETSAT. Let's take a
version
look at
is
them.
the A variant.
3, 2, 1, feu, allumage, décollage.
So the 124, RD-124 is used in this launch, and RD-110 is used in the A variant. So these are all the satellites Arianespace launched for has launched for what is it?
So there you have it. Arianespace has launched all the satellites for EUMETSAT. Those were the 12. And today, of course, we are launching the 13th satellite, Metop-C. It's en route right now to its final slot in space. And there on the right-hand side, you can see we lifted off from the Guyana Space Center on the northeast.
So as you can see, we're approaching orbital velocity.
Guyana,
they still need 2
Galileo
kilometers per
is
second.
the name of the tracking station here at the Guyana Space Center. We're using telemetry to track the vehicle. During the flight, Soyuz sends information to the ground stations along its flight path, and they then send that data to the teams here at the Guyana Space Center.
So right now they are putting the satellite into an elliptical orbit, which is around 230 kilometers by 813. And they are
after the event and check out how
after the Fregat burned, they will wait 40 minutes, go up to the highest point and ignite the engine again, and then they will put it into a orbit.
That was the one in
French Guyana,
and then we'll be picking up the signal next
almost
in Bermuda in the
orbit.
Caribbean. Then we've got St. Hubert, that's in Quebec. New Nausea in Australia.
So for the other launch of the week,
this is the scheduled moment when we pick up the signal in the tracking station in Bermuda.
7 hours. The Pegasus XL, which is one of my favorite rockets, is going to launch. And
we just have confirmation of that
Saturday
from the range operations manager. Our
no, Sunday morning, really early morning for me. There is an Electron launch
back to the CSG, the Guyana Space Center, but it has to go via Moscow to be validated first, so it can take
separation.
A little time for it to get from the launcher to us for confirmation. That's the scheduled moment now for the engine shutdown. Separation
as you said, it takes some time because all the data is first relayed to Moscow, and then from Moscow it is relayed to Kourou, and then it gets validated
to be happening to the launcher and the satellites. So they are
I bet
a
Pegasus
simulation
XL gets scrubbed again. Well, it was given the go
in
today, so I hope it launches.
So we're looking at the frigate upper stage, that round circular structure back there. It's what's left of the launch vehicle, and it's getting ready to switch its engine on. We're in what we call the pre-burn phase.
So they're almost in orbit.
It
will just take a few.
Fluids back into the back of the tanks to make sure there's enough propellant to ignite
just over
the
a
engine
minute
properly.
for this.
It's a little bit like when you
Fregat
press
to put
the
it into
throttle in the
orbit.
car and you get pushed back against the seat. This is the
I
scheduled
will
moment
take
now for the frigate upper stage
a little bit less
to switch on
than
its engine,
3 minutes.
which really signals the next phase in the journey when frigate takes the wheel.
So the frigate will, after separation of the satellite, will deorbit and burn up in the atmosphere.
And he's confirmed that we now have the first ignition of the frigate upper stage's engine. Some of the teams here in the control center. If you look at the right-hand side of the screen, you can see the frigate upper stage there. It's that round circular structure with 6 spherical tanks, which are organized in a circle.
So it uses
4
hypergolic
of those for
propellants.
2 of those for avionics. That's the sort of thing that you find in the cockpit of a plane. Flight control systems.
So the fuels when they're mixed, they immediately
And the satellite is attached using a very special dispenser or adapter. The frigate upper stage is a really clever piece of kit. It was originally designed as an interplanetary probe to travel around the solar system. And it was adapted to fly on board Soyuz.
But the Pegasus XL
has switch its engine on and off up to 20 times.
Weird problems.
And that's why it's able to take its passengers pretty well anywhere they need to go. And it makes Soyuz ideal for launching all kinds of spacecraft to all kinds of orbits, including constellations and, of course, observation satellites and meteorological satellites like today. We're using that engine twice today to separate our satellite. And that's our flight path. So we're now picking up the signal at the tracking station in St. Hubert.
How did the Pegasus kill Zuma?
Canada?
It was launched on a Falcon 9, so
I believe that the aerospace industry
how could a Pegasus
the Canadian Space Agency has its head office in the
killed the Zuma? Explain the payload adapter.
And we've been hearing how Metop-C is going to be providing
the Pegasus was made by Orbital ATK, not by Northrop
from 12 hours to 10 days in advance, and it's going to give us vital information about the composition of the atmosphere, the oceans, the land surfaces. Very important if we are to get a handle on how our planet's climate is changing, which I'm sure you all agree is absolutely paramount now as we see temperatures rising.
Slow internet.
frigate getting ready to switch its engine off, and that's what
that
it
was the
looks
first
like.
burn.
This is the scheduled moment for the engine
Confirmation of shutdown.
For the onboard computer to send the command. And this next phase of the flight is known as the ballistic phase. That means that we have no propulsion. Ballistic means travelling without propulsion and coasting without the engine. Sometimes we have very long ballistic phases, but for this flight it's not too long. It's about 38 minutes. And we're going to take a break in a second to...
So we'll do a barbecue roll now, which basically
for the ballistic
spins
phase.
around its axis.
During that time, we will have a planned gap in visibility of the ground stations. That means that we are scheduled to lose...
even on the whole...
We have confirmation there that the engine has indeed switched off. So, yes, we'll have a scheduled gap in visibility. That means that we are scheduled to lose the signal at the tracking station in St. Hubert. We've started them 15 minutes ago from the pad at the Guyana Space Centre. This is what it looked like.
Northrop Grumman have had their grubby hands on Pegasus XL for long enough to polish it up by now. Yeah, they did. Well, it was actually already showing problems when it was still orbital ATK, so... Wow, nice shots of launch. Those are really nice. So yeah, I was gonna look up the RD01 24 engine. And it needs to be like this. And as you can see, it is separate. No, that's not the RD124. That's the engine that is on the second stage of the Soyuz, or third stage if you want to call it that. And the 107 is the this is the engines that are on the first, the boosters in the first stage, and they run on the those verniers run on the same engine. They actually do. They are connected because they use the same turbo pump. As shown here in this figure, you can see that. They are connected indeed. Okay, interesting. And so if I go back to the RD124, I think that's not what I want. Are there no verniers on this engine? Let me check Russian space web. Let me see. I think the engines. Interesting thing. Oh yeah, there it is. Here it is. Yeah, they are in fact connected. I was correct. They are connected. The verniers are connected. They have the same turbo pump, which would be reasonable would be logic, because why would you have a here you have Scott Manley also pointing out that it is in fact 5 engines and not the 20 engines. So yeah, it's time. Now we need to wait for about 50 minutes. No, it's less. It is 24, so 20 minutes, 17 minutes. We need to wait for 17 minutes. So yeah. What are they talking about? Okay, wow. Yeah, this was launch.
Perte nominale de la télémesure par la station de Saint-Hubert et trou télémesure prévu.
Yeah. Because I need some sleep. I'm going to round it off here, and so yeah, thank you for watching, and if you enjoyed this, please like, share, and if you stumble upon my stream and haven't subscribed yet, go ahead and quickly subscribe. And yeah, if you follow me on Twitter, and do make sure to be around sometimes when I stream. And yeah, as always, ad astra to the stars.